All right, welcome everyone to MapTime Davis. This is a workshop that's put on by MapTime Davis and UC Davis Data Lab. My name is Michele Tobias. I am the geospatial data specialist at UC Davis Data Lab, and also one of the people who participates on MapTime Davis Council to bring you the MapTime Davis workshop series. Of course, my slide advancing things are not working, so as I get myself settled again with presenting. So today we are doing Intro to GIS with QGIS. So today is going to be a good background introductory workshop for those of you who are new to GIS in general or new to QGIS. So we're going to start with some basic concepts. So for those of you who have no experience whatsoever, this will be a good place to start. And for those of you who have GIS experience, we won't spend a ton of time going over the basics. So hopefully it'll just be a nice quick review of some of the terms that I'll be talking about. And then we'll jump into a hands-on workflow with QGIS. And hopefully this will be a really good intro for everyone and meet a lot of different needs. Oh, and I also want to say a special welcome to our folks who are participating in the Environmental Justice Fellows Program who are joining us today from the Transportation Department. We actually initiated this workshop because of a request from that program, and it's really cool that we got to do this again for the second time this year because we've got quite a few people on the call, and that it just makes me happy that we get the chance to teach something that's of interest to so many people. So today's teaching team is I will be your instructor today. I've taught this workshop many times at this point, and it's one of my favorites to do. We also have helpers behind the scenes. So if you see answers from Naomi Kalman and Alex Mandel in the chat, they are also part of MapTime Davis Council and helping me out behind the scenes today and answering questions. But also you guys should feel free to answer each other's questions. If someone has a question you have an answer, by all means help each other. We definitely appreciate folks engaging in that way. And the chat, again, is going to be your best tool for communicating with all of us on the instructing team today. So really quickly, what is MapTime Davis? If you're new to MapTime Davis, you might be thinking that's a funny name for a workshop series. So MapTime is literally time for maps. It is a meetup that happens all over the world at this point. It's kind of an international thing. A lot of major cities have MapTime meetups at various times of the year. Some are more active than others, and ours has been active for, I think we're just coming up on our 5th anniversary in the fall. So we'll turn 5, maybe we'll have a birthday party in the fall. MapTime Davis is kind of flavored a little differently than other MapTimes because we're housed on a university campus. We tend to be a little bit more research oriented and focus more on research type tools. And when I show you what's coming up, you'll probably see that in our schedule. The effort is coordinated by UC Davis Data Lab's Spatial Sciences Research and Learning Cluster, and in particular by MapTime Davis Council. This is a group of folks who've been working for the past year to produce this. And we are, faculty, staff, students, community members who get together, and put this together and make this happen. And this is the first year we've done this council approach, and it's been really good. And a little bit about Data Lab. Since I mentioned, we are also presenting a Data Lab workshop today. Data Lab, our mission at Data Lab is to increase UC Davis's research impact via data-driven expertise, and we support the next generation of data-capable researchers and students. The way we do this is through things like workshops, like you're here today for. We also have weekly office hours where people can come and meet with us and ask us questions about research and things they're trying to do. We're also oftentimes embedded in research projects, so we have the ability to join research teams and provide data science expertise there, and many other things. So check out our website, datalab.ucdavis.edu, for more about what we do and if there's something that we can help you with. So upcoming events for MapTime, there's more workshops also in Data Lab in general, and I'll give you a link to the the schedule that's coming up in a second. But we've got some really cool stuff coming up in the upcoming weeks. So next week we'll take a break, but after that, we've got a workshop in R for climate data with Andy Lyons from UCA&R. We're going to be learning about engaging underserved communities with GIS from some folks in private industry in Sacramento, which is going to be a really good workshop. After that, I'm teaching a spatial SQL workshop. So if you're interested in learning how to use databases and communicate with databases, I will be teaching that in about a month. And then we'll end up the quarter with Google Earth Engine workshop by Luke Salvato. So we've got a lot of cool stuff coming up. Feel free to join us for any of that. Now's the call for getting involved. If you're interested in participating, we've got a lot of good ways to do that. Obviously, you can come to workshops. You can help us plan. You can be a helper behind the scenes in our workshops, and you can even present workshops. Another thing is the application period for Maptime Davis Council is currently open. Applications are due May 6th, and I'll give you a link to that as well in the chat and once I finish with the slides. And the goal of this is to allow people to help shape the direction of Maptime Davis. It's also a really good networking opportunity to allow you to meet people in our community, both on and off campus. And it's just a nice way to get more involved in the geospatial community on and off campus. So I would encourage you, if you're interested in getting more involved in Maptime and helping us plan workshops and other events, we can use help. There's always more things to do. So please submit an application if you're interested. And if you have questions, you can always email me and we can chat, or you can come by drop-in hours and we can talk more about what that looks like. But feel free also to reach out to any of the other Maptime Davis Council folks as well. Okay, so I'm gonna jump out of this real quick. I'm gonna stop my share just briefly while I give you the links that I promised you. So in the chat, you're going to get a list of a bunch of links. The first one is the materials for today's workshop. There's also a link in there for the upcoming Maptime Davis schedule, including links to register for upcoming workshops. The Data Lab calendar, which has all of our events for Data Lab and links and things like that. And also the application form for Maptime Davis Council, if you're interested. That also has some more information in the form itself about the commitment and the timing and stuff like that. All right, do we have any questions before we get going? I noticed there was some stuff in the chat. I'll let Naomi and Alex tell me if there's anything I need to know. Okay, not hearing anything, then I will get going. So that first link I gave you in the big block of links is the link to the materials we're going to be working with today. So I'm going to share my screen and show you that. I can get rid of that guy. Okay, so this is the link to the workshop materials. It is a page on GitHub, and these materials stay online all the time. We leave them up, and you'll notice right before a workshop happens, you'll see a whole flurry of edits. And that's because I'm just updating things for the current version of the software. But yeah, so these stay online, so don't stress. We're not going to take them down, so you'll have access to them all the time. They just live here. You'll notice we also have some links to videos. If you ever wanted to watch, watch me present this again at some other point in time, we post the videos here as well. The best recording right now that's available is the QGIS North America conference video. That one's 4 hours. So it's a really slow, nice pace. So if we go too quick today, you might check that one out. It is with an older version of the software, but essentially very little has changed in the software that would affect this particular workshop. So it should be pretty similar. And then we'll also, if we can, we'll post this recording for today later. Okay, so workshop preparation. I'm going to assume that you have installed QGIS if you're working along with us. You don't have to work along though with us in the workshop. You can certainly just watch. If you only have one screen today, like if you don't have a dual monitor set up, or you're working on a laptop and you've got a small screen, I would recommend just watching and coming back to the materials and working through them on your own later. It's really hard to do this without two monitors. So because the video needs to be fairly large to see what's going on. So just a word of warning, you will not hurt my feelings if you decide you just want to watch and you don't want to follow along click by click. It's totally up to you. So our workshop aims today is, my goal is to get you the fundamental concepts and skills you need to build on for later. So we can't teach you everything today. I've been in the field of GIS for a couple decades now, and I can tell you I'm always learning, so we can't teach you everything in 2 hours. But I want to give you a good foundation in order to have the terminology and the vocabulary you need to get started and understand the things that you'll need for learning later. So your prerequisites today, I mentioned earlier, I'm going to assume you guys don't have any GIS experience. And we're going to start from the beginning, but we're going to move quickly. This will be a good intro for folks who are coming new from having no GIS experience, but also folks who are coming from other software or other programming languages that want to learn specifically QGIS. So our learning objectives today, just to define it a little bit more closely, are by the end of this workshop, I expect you'll be able to have a good understanding of the basic terminology for GIS and geospatial concepts. We're going to learn about two specific data formats today, raster and vector data. There are other data formats, but those are the two you'll most frequently encounter. So it's a good place to start. We'll learn how to work with QGIS specifically to set up a project, add data, perform some basic analysis and selections on our data, and how to do some work with how to symbolize data. And then we'll also look at, if we have time, making a map for printing or putting in, your journal articles or things like that. Wait, so that's the plan for today. I'm going to make this text a little bigger. So I'm going to start out today in our workshop materials, and then later I'm going to switch to QGIS and show you what I'm doing. I am still going to be following along with this document. So if you have two screens, you can put this over on the other screen. And if you get tripped up somewhere and need to catch up, this will be a good reference for that. So I will follow the script pretty closely, but I won't always be showing you the text. However, to start, I will, because it's got my graphics and things like that. Okay, so what is GIS? You're here for intro to GIS, but maybe it's a good place to start. Like, let's just define this thing. So GIS can stand for, it's an acronym, it can stand for a couple different things. Most commonly, you hear people refer to Geographic Information Systems or Geographic Information Science. And depending on what aspect of the term people are interested, they'll use it in different ways. However, they won't usually tell you what they mean, they'll just say GIS. So in terms of Geographic Information System, that typically refers to things like the software and the tools that we use to create spatial data and investigate spatial relationships between our data. When we talk about Geographic Information Science, that's really the framework that we're using to ask and answer questions about the spatial relationships between the data. So it's kind of splitting hairs, but some people will make a distinction between the two, but they won't often tell you which one they're actually talking about. So just think GIS can either refer to the software and the tools you're using, or it can be the process that you're going through to ask the questions. So it's kind of both a noun and a verb. So to refine this a little bit more, today's workshop is really focused on QGIS, but what is QGIS? And we had a little discussion before we started the recording about the difference between this software and other softwares. And essentially, QGIS is a tool that does desktop GIS. It's similar to other products out there. There's quite a range of products that, especially if you do international work, you'll encounter quite a few other tools available as well out there. So this is just one tool that does similar things to some other tools out there. So QGIS defines itself on the website as a user-friendly open source geographic information system licensed under the new general public license. QGIS is an official project of the Open Source Geospatial Foundation. It runs on Linux, Unix, Mac, Windows, and Android, and supports numerous vector, raster, and database formats and functionalities. So what does all that mean? Like, that's a great summary for those of us who've been in this industry for a while, but if you're new, it's like, that's a lot of words. So QGIS is a desktop GIS. What that means is it's a tool that you run on your computer, and it has windows and forms for you to fill out. It has visual tools, so you don't have to program to work with QGIS. You can use the graphical interface to interact with it and use it to ask questions of your data and arrange data and things like that. So this is really similar to how you would normally interact with any other like Windows based and Windows in the general sense. Like Mac follows this system as well. You have windows that you can move around on your computer. So this will look pretty familiar if you're just a person who's used to general computing. QGIS is open source. That's a little different from some of the other tools that are out there on the market. What this means is that the code that underlies the software, the code that drives the software and makes it work, is available for you to read and modify should you choose to, but you do not have to. So it's really nice if you need something changed in the software, like maybe something doesn't work the way it's supposed to. If you needed to go in there and fix it, you could. For those of you who are new, you're like, oh no, I don't want to do that, and you don't have to. But the nice thing is that because everyone can see the source code, if something's wrong, it means anyone can help fix it. So fixes happen a lot quicker in this kind of environment, especially with QGIS. You actually have access to what they call the nightly build, the things that are happening every day getting fixed. I don't recommend working with that one unless you have a reason. The stable version is better for those of us who are working with it for work purposes and not developing, but you can get those fixes very quickly. It's also nice for those of us who need to do repeatable research because we can say exactly what the code is doing because we can go look at it if we need to. For those of you who are less familiar with programming, you may have to find someone else to join your team to help with explain that if you needed it, but it is available. And so you can actually see that versus proprietary closed source software where you can't actually see what's going on under the hood. So in terms of repeatability, it's really nice to have that option if you need it. And the last part I want to talk about is the statement that QGIS is an official project of the Open Source Geospatial Foundation, which is also known as OSGeo. So OSGeo is a nonprofit. It works to help foster the adoption of open source geospatial software and also the development of it. And it is an organization that helps support a number of tools, some of which you don't know you are dependent on, but you are like GDAL, which is the library that handles projections in the background. That's an OSGeo project, and many, many other things. It's a really cool organization. It does really good work. And just for full disclosure, I'm actually on the board of directors. I'm in the middle of serving a 2-year term, but I actually wrote this workshop many, many years ago, and I've been a charter member of OSGeo for a while as well. So feel free to ask me questions about that, but I like to just let people know that I'm actually a member of this organization on the board currently. So all of that, it's a lot of words to go through. Why do you want to use QGIS versus something else? There are a lot of other tools on the market. I know a lot of you on this call are familiar with the tools that come from Esri, like ArcGIS and ArcGIS Pro. But you also may be familiar with other tools like GRASS and Saga and things like that. So why QGIS? It's a really robust, powerful desktop GIS. That's why I use it. It does everything I need to do. A lot of the reason why I recommend it to other folks on campus is because of that, and also because it runs on so many operating systems. Unlike some of the proprietary software that only runs on Windows, if you work on Mac or Linux, you can still use QGIS because it works on all that. I've actually heard people have installed it on a Chromebook. I haven't tried that, but apparently it's possible. So if that gives you an idea of the versatility of this software, hopefully that helps. The other thing is that because it's open source, QGIS is free. You don't have to budget for it. It's available and there's no license to deal with. So it doesn't expire, it keeps running. Bug fixes are really frequent and the community is really responsive, like the programming community. I have had some things that have gone wrong where they made some changes to the way the software works and it broke a project I was working on. And I submitted a bug and they realized, oh, we didn't realize that making this change was going to affect people this way. And within a day it was fixed. So it's really shows you the power of this community, and that I think it's really nice that people care and listen and they want to make a tool that works for the most people. Also, it integrates really well with other tools. So you can use QGIS with R and Python and PostGIS. And if you come to the workshop in about a month that I'm teaching, you'll see you can connect it with Spatial Light. It's really powerful. It connects to a lot of things. It also works with other GIS programs like GRASS and Saga and Orfeo and a bunch of other stuff you've probably not heard of, but if you need it, it's there inside QGIS already. So it's really nice to have access to those tools if you need them and not have to have a bunch of different software on your computer. It also has access to native access to open data formats like GeoJSON and GeoPackage. QGIS writes the formal official GeoJSON version, unlike some of the proprietary softwares that have come up with their own version of GeoJSON. If you want the actual official spec, QGIS saves that natively, which is nice. It's good if you're using open formats to use the actual spec for that. For those of you who work internationally, QGIS also has been translated into more than 40 languages, which is super nice for folks who need to work with it in something besides English. It's been translated into several languages. Some of them are still in process, but I think it's a good place to start. And if you work internationally, it will be a nice way to collaborate with other folks. And finally, QGIS is growing in use by state and local and federal and international governments. There's some user groups forming in the state right now. Some of them have been going on for a couple of years now, where folks are looking at using open source tools. So we're seeing a little bit of a shift there. So it's good to know QGIS, even if it's not your tool of choice for every day. It's really good to know about it because it does solve a lot of those problems, and in terms of like licensing, and you can get access to it if you need it. All right. I'm going to pause for a second and see if there are any questions that folks have. You can put them in the chat, and then our helpers can help me know what I should address. If you don't have any, that's fine too. Let's get myself a little bit more tea here. Okay, I'm not seeing any questions. I know sometimes it takes a bit of time to type them. So I'll check back on the chat in a little bit. So if you have questions, you can still put them in there and we'll make sure that they get answered. So what I want to do is soldier on here and do the last little bit of concept before we jump into the hands-on portion. So I want to talk about data types before we see them in action. So there are two of the most common data types you will see working with geospatial data are vector and raster. And we're going to see these today. I have a bit of an illustration here for you. So these are two different types of data. They store data differently, and they have advantages and disadvantages for different applications. So vector data is typically, we like to say that the data types there are points, lines, and polygons. So these are the kinds of things you would draw if I said, you know, hey, get out a sheet of paper and draw a map, you know, to your favorite lunch spot from campus or something like that. You would probably take your paper and you would draw things like streets, and you draw those as lines. You might draw, you know, the edge of campus as a polygon because there's a lot of grass. Maybe we would make that green. And then maybe the place where you want to meet up for lunch would be a star. And maybe there would be a couple other points on there for like saying, okay, you're going to go past the post office, which is here, and then there's the lunch spot, and make that a star. That kind of mapping is vector data. So you're using points, lines, and polygons. It's really good for discrete data. So objects and things that can have bounds around them. So vector is good for discrete data and objects. We can use it for continuous data. So if you've ever looked at like a topo map, like a USGS topo map, where there's lines to indicate elevation, that's an example of using vector data to illustrate continuous data. So we put like, in my example here, like, maybe this dark purple line is 100 meters, and maybe this is 90 meters for the next one and 80 meters for the next one. So we know that somewhere in between here is, between 100 and 90, but we don't know precisely what that is, but we have enough information. So we've made that continuous field of elevation into something discrete and represented with lines to use vector data. Obviously, that you can think of probably why that is advantageous in some situations, but not in others. Same thing is true of raster. There are trade-offs. So raster data down here at the bottom is, instead of using discrete objects, everything is represented on a grid. So we have measurements everywhere across the space that we're measuring, and it's divided up into, in this case, squares. That's the most typical way you'll see raster data, is chunked up into squares. And so it's really nice for representing continuous data. So for example, in my continuous raster illustration right here, I've displayed the data in discrete colors, but maybe this point up here is actually 109 meters, and this one over here is 100 meters. Maybe this one is 89.7 meters. So we can contain any value in each of these cells, and each cell contains some measurement, and it could be a continuous measurement. It doesn't have to be integers. It could be decimal data and things like that. So raster is really nice for being able to contain that kind of information. It holds continuous data, so it can represent continuous fields like elevation or temperature, precipitation really well. On the flip side of that, you can use raster to represent discrete things, and people do. It is really common in like agricultural data to have like crop types in a raster. Because of the way that the other data sets work together, it works nicely to have that in raster data format. But you can kind of see when I'm representing something discrete like points, they kind of get blocky and things get pixelated. And if this is a road, I may not know precisely where this road is in this set of pixels, because it probably isn't doing this. Like it's not a stair step kind of feature. So it can get a little awkward. And obviously, like if I really wanted to represent discrete objects and do it very precisely, I would choose vector over raster. But the same is true if we flip it for continuous fields. Raster data tends to be a better way to do that, but we can represent it with vector data. So just something to be aware of. And we're going to be working with both of these data types today. So as you work with them and try them out, you'll see, you'll get a better intuition for how these things work, and maybe what kinds of data types you might want to work with in your own research and your own projects. Okay, so I think that's covered all that. Are there any questions I can answer before we jump into the hands-on part of the day? I'll give you a second to type if you're typing, and just say, but also don't stress if that was a really whirlwind explanation. Again, we are going to see both of these data types in the workshop materials, and you'll get a better understanding of how to work with them and sort of what they're good for, and the kind of data you might want to work with as we give them a try. Okay, I'm not seeing any questions in the chat. Oh, here comes one. So can we combine vector data with raster data? So you can have them both in the same project, and you'll see that today. And there are ways to extract information from one, like from a raster into a vector and vice versa. So it is possible to exchange information between those two formats, and also convert. Like if I have a raster and I need it to be a vector, I can convert them. Sometimes that gets a little weird depending on the resolution and things like that, but there's ways around that. And you can come by drop-in hours too if you want to ask some really specific questions. But yes, they do work together, and you can exchange information between them. I'm seeing a question. Does traffic travel time, it's sorry, my chat jumped up and I couldn't read it anymore. So just traffic or travel time mapping, like Google Maps use raster or vector data or something else. I without seeing actually like their actual data, my guess is vector data. I see Alex also agrees with that. So the way that road network data can work is it's a special kind of vector data where you have lines that represent the roads, but there's also information about the directionality on those roads and also things like speeds. So you can have like multiple pieces of information about that road. And you'll see when we look at the vector data today that we have, we can basically attach a data table to those lines and have multiple pieces of information. So it could be things like, you know, the speed limit, but also information about what the current travel speed is on that road, which obviously can be very different than the actual speed limit that was set legally. So yeah, road network data can be tricky just because it's complex, but today you'll get a little bit of intuition about how vector data works in general. But I think thinking about things like road data, because you see it on your phone when you do your turn-by-turn directions or check traffic, is a good example to think about. All right, I'm not seeing any more questions popping up right now, but feel free to add them as we go. And if there's something pressing that I should answer, Alex and Naomi will stop me and say, hey, we have a question. So feel free to type those in the chat as we go, and we'll try to make sure that your questions get answered. Okay, so let's get started with some actual hands-on things. So what I want you to do is, if you're following along today, we have data that is in this box folder. I'd recommend opening it in a new tab because otherwise it'll navigate away from the materials. But they're in the chat, so you can always go back to the link. What that's going to open up is a page that looks like this. And you can, zoom things out of the way, which you guys can't see. When you go to this page, there may be a little banner that shows up across the top that you can dismiss. And then what you want to look for is this download button. And when you click download, it will let you download all of the data that's in this box folder as a zip file. So you're going to put the zip file somewhere where you can find it. I like to make a workshop folder and just put it in there so I can find it easily. And then you're going to unzip it. So once you download the data to a place where you can find it, you're going to unzip that file with your favorite unzipping tool and just put the data. Basically, the key here is put it where you can find it. If it puts it somewhere weird, move it. Depending on how your computer is set up, it may download somewhere else, like a downloads folder, and you might want to put it somewhere else. So while you're doing that, I will give you a brief description of the data that we have today. So yeah, you don't need to log into Box in order to download it. It should be able to be downloaded without logging in. But if you do have a Box account, feel free to log in. It doesn't really matter. So our data today, we've got both raster and vector data. We have a digital elevation model of San Francisco. So that's elevations. It covers the entire city. And that is raster data. As you may have guessed, because we talked about raster data being good for things like elevations. So that's the raster data we're going to work with. We also have several vector data sets as well. So we have a street data set for the streets in San Francisco. We also, so those are lines, you might have guessed. We have a point data set, which is trees. And then we also have seismic hazard zones, which are polygons. So you're seeing points, lines, and polygons today. And then we also have a polygon for the city of San Francisco boundary. That is just kind of helpful for knowing kind of where the edge of things are, especially you'll see when we load the DEM, it's going to look a little bit funky. And so that shoreline might be helpful to have on hand. So that's the data we're going to be working with today. We're going to load both raster data in TIFF format. We've got some shape files, which is a really common format for vector data. And then we also have a CSV file. So you can see how to load data from a CSV. So the trees, I believe, are actually a CSV file. All right, so hopefully you guys have the data. In fact, if you want to, if you look at your Zoom tools down at the bottom, mine are refusing to show themselves to me at the moment. Yay, Zoom. So you can give me like in the reactions, there should be a green check mark and a red X. So if you're ready to go ahead and click on the green check mark, and then I'll see that and know we're ready to move on. But if anyone's struggling to get the data and you want me to wait, go ahead and click the red X, and then I will know that you need some more time. Okay, I see one red X right now. If you're having trouble and our helpers can help, feel free to post a question in the chat. And then they can help get you going. So I'm going to assume today at this point, like you will need to have had QGIS installed if you're planning on following along. If you don't have it installed or you just started the download, it might take a while. So feel free to just watch at this point. If you do want to follow along, great. I'll show you step by step how we do all of these things, but it's perfectly okay to just watch today and not try to follow along, because I know that can be a challenging thing to do, to manage all of these different windows. So I'm going to go ahead and get started. I'll move a little bit slowly so those of you who are still getting the data can catch up. But this is the point where I'm going to move the instruction materials here. I'm going to move them off to my other screen so I can show you what's going on in QGIS. So the first thing that we're going to do to get going is we're going to start QGIS. And depending on what operating system you have, you'll start this in whatever way you normally start programs. So I'm on Windows 11, thanks to a surprise update about a month ago. So I'm just going to search for QGIS and I'm going to choose, I have multiple versions. That's the cool thing about QGIS. You can have older versions if you want. There are reasons why you might want to do that. But I'm going to go to QGIS version 3.24.1. It was the stable release when I downloaded it, I think 2 weeks ago or so, to get the latest version. So I'm just going to go ahead and click on that and start it. But again, if you're on a different operating system or you've customized yours, you may have a different way to start programs, and that's fine. So I'm starting QGIS, and I'm going to drag this guy over onto the right screen so you can see him. So this is what it probably looks like if you've never used QGIS. It has some news here. And if you have used QGIS, it'll actually offer up a panel with projects that you've been working on. So depending on if you've opened this before or not, you may see a slightly different view. That really largely doesn't matter, but I just want to point it out that if yours doesn't look precisely the way mine does, don't panic. It's going to be okay. There's a real good reasons why you might have a slightly different version. And I have a user profile set up to show you what a new user has. So you don't see the version I work off of, which has a whole bunch of plugins enabled and other things that you don't need for today's workshop. So this is QGIS. What we're going to do is we are going to open a new project. There are a couple ways to do this. You can either click on this little icon up here in the upper left corner that looks like a little blank page with a dog here, like the corner turned down, or you can go to project and new. So the easiest way for me to tell you to do this is go to the project menu and click on new. So I'm going to go ahead and do that. And this is what my QGIS looks like. Just fresh started up, nothing loaded, kind of blank. But that's okay. We're going to add some things here pretty soon. I'm going to hover over this edge here. So it gives me the drag handle, and I'm just going to click and drag to make this a little bigger, just because I know it's going to need to be bigger. So what are we looking at here? When we load some data, you'll see we have this layers panel here on the left-hand side. It's blank right now, but when we load data, we'll see it sort of like a table of contents of the different data that we've loaded up. So that looks pretty similar if you've used other GIS programs. A lot of them have this kind of layer list. There's also in QGIS, this one's a little bit more unique. I think there's a browser panel. And this actually will let you browse through the files on your computer, and you can load data this way. I tend not to use this just because I have a box drive connected and it gets really slow with Box, but that's Box's fault, not QGIS. So I tend to not use this as much, but it's there and it's helpful. When we load data, you'll see the data, actually the shapes will show up in this middle big blank area. And then we have a bunch of tools up here at the top and also menus at the very top. And I'll do my best to point you to those when we need them. I will say sometimes the toolbar can be a little tricky because sometimes they'll load in different places. So I may have to indicate things in a different way for you on that, but we will feel that out as we go. Okay, so that's QGIS. Step one, we open QGIS and we open a new project. We are well on our way. I know maybe that doesn't sound very exciting, but you know, it's the first step in some very big steps to come. So we want to import some data now because while this was fun for a few seconds, it's getting boring. So let's add some data and we can do some things that will be more interesting. So what I want to do is I'm going to load data with the data source manager. The icon for that on my screen is here. I'm moving my cursor over it, so hopefully the movement will catch your eye. It looks like 3 cards stacked up. So you can click there, or you can go to, is it the, oh, there it is, the layer menu. Obviously, when I'm working, I know what the tools look like, so I just go for them. But in terms of teaching, I think it's helpful to be able to get things from the menus. So if you go to the layer menu and the first item on the layer menu is the data source manager, that's a reliable way to find that. It opens the same thing. You can see it has a little icon that's the same as well, but in terms of finding it in case your tool's loaded in a different spot. So I'm gonna open the data source manager, and this is what this tool looks like. This is a little different from some of the load interfaces you probably have worked with other programs. Down the side here on the left of the window is a list of different data formats. This is why, one of the reasons why when I teach this workshop, I make sure we talk about the difference between raster and vector data, because you need to know if your data is raster or vector to know how to load it. And you'll notice there's a whole bunch of different types of data we did not talk about, but we will talk about vector, raster, and then the delimited layer as well. So to start, we're going to load up, if I'm looking at my workshop notes to make sure we go in order. So we're going to start with raster data. So I'm going to click on this raster data button here on the side, and then this is going to allow me to search for raster data. Pretty simple interface to start. So basically, I want to tell it what is the source, what is the data I want to load, and I'm going to click on this button over here with the 3 dots. That's going to let me navigate in my file system and find the data that I want. So I'm going to navigate to my folder where I saved my workshop data. So I put mine on my D drive in my workshop data folder. And I'm going to go into my folder where I know my data is. So the first file that we want to load is this dem_sf.tif. So DEM for digital elevation model. You may notice there's another file with a similar name that is an auxiliary file. We do not need to tell QGIS about that file. It will see it because it will know like the files are named similarly, and it will find all of the auxiliary files it needs. So we just need to indicate the main file that we want to work with. So again, I'm going to click on dem_sf in my workshop data, and I'm going to click open. It's going to ask me some other things. I can have other options to load the data if I want, but I don't think we need to deal with any of these for today. So what I'm going to do is, that all looks good to me. I'm going to click add. And when I click add, it's going to ask me about what is the transformation I want to use. The way you work with this interface, this has to do with projections, which we're not going to talk a whole lot about today. The trick is to look at the list of transformations, look at the accuracy, and then what area it's good for. There's notes on the side, and kind of make it a good decision. If I'm working fast, I'll usually just take the first one on the list because it's probably fine. But I think I said in the workshop materials, we want the one that is number 43. So I'm going to look through the list and see if I can find that. I'm not seeing that today. Maybe the list changed. So what I want to do then is It's the 13th one, Naomi says, number 13. Oh, I was looking for the number in the wrong spot. So I'm looking for number 43 here. Thanks, Naomi. It's nothing like teaching a workshop to make you blind to things. All right, so on your list, you may see it might be line number 13 for you here too, but really basically if I'm faced with this decision on my own, what I do is I look for one that has a pretty nice low accuracy number that's fairly low, because that means it's a better accuracy. And then I also look at what area it's applicable to. So like, I wouldn't want to pick the one below it because that's for Nevada, and we're working in California. So obviously the next one on the list is probably a less good choice. But anyway, so I make my decision and then I'm going to click OK. And then I'm not going to close the data source manager yet because we're going to add some more things. But if I just move it out of the way, you can see I've loaded up my raster now and it's black and white. It doesn't really look like the peninsula for San Francisco yet, but we will fix that in a moment. Okay, so we've loaded our raster data. Now what we want to do is load our vector data. So we're going to load some shape files. And then after that, we're going to load a CSV. So you'll see how to do the three most common data situations that I come across in my daily work. So on the vector tab, so we're back in our data source manager and I want to change from raster. I want to click on the vector option here. So again, now we're going to be looking for vector data. And that's why you need to know the difference. Thanks, Alex, for answering the questions in the chat. So what I want to do is click on again, the three dots button here to find, basically navigate to the file that I want to load. Okay, so mine defaulted to the folder I was just in. Yours may do the same, or you may have to navigate back to where you saved your workshop data. But so I want to load three different files. I'm going to load my streets, my seismic hazard zones, and my shoreline. And I don't have to go through this one at a time. I can actually select them all at once if I hold down, in Windows, if I hold down Control. I'm sure Mac people know the option to select multiple ones. It's probably something similar to Control. So I'm going to pick seismic hazard zones.shp. Remember, all of these auxiliary files that come with a shapefile, QGIS will find on its own. I just need to tell it the shapefile that I want. All right, so I've selected my seismic hazard zones. I'm going to hold down Control on my keyboard and select my shoreline.shp. And then I want my street center lines.shp. So I've highlighted those. And then I'm going to click Open. You can also do this one at a time. You just have to click Add and then go back and select the next one and click Add. But I've got all three of them listed, and you can kind of see if you look through here, it's got three different paths listed. So I'm going to click Add on that because we don't need to deal with any of the other options. And you'll see it's going to ask me again, which transformation do you want? So I want this one, the one that's, again, same one we picked before because these are all the same projection. I'm going to click OK. And all of the details, if you need to reference anything, if I went too quick, they're in the workshop materials. So if you need to see the text, that's all there. And then you can kind of see it's added some things and oh, it picks some very ugly colors. It picks them at random. For a while, mine was stuck in like a pink loop and everything was like hot pink. But now I see we've gone into the reds and tans. We will fix the colors. As a cartographer, it makes my heart hurt that these are ugly, so we'll fix it. Okay, so we loaded raster data and we loaded shapefile vector data. The last thing we need to do is load some CSV data, which is a really common way to get point data from folks. It's easy to store in an Excel file, so a lot of times you'll get it that way. So to load my CSV data, I'm going to pick on my data source manager, I'm going to pick delimited on the side here. So we did raster and vector, and now we're going to look at the delimited option. Delimited means like if you probably have heard of a CSV before, which stands for comma separated value. So the comma is the delimiter. And if you open up a CSV file in a text editor, you'll see each of the values, the things that go in each cell have a comma after them, which tells the computer that that's where basically to put the lines for the columns as it's putting it into a table format for you. So you can have different delimiters. It's not uncommon to have a tab delimited file, or in the world of GIS, you'll actually see pipe delimited pretty frequently because who uses pipes? So because we don't tend to use pipes in our everyday world with typing, it can be a nice way to use to assign that as a separator because people won't use it accidentally incorrectly. Sometimes if you have a lot of like free-form text, people will put commas in it, and then some tools can get confused because there's too many commas and it thinks, is this comma a column or is it just a comma? So if you use things like pipes, it'll make that not an issue. But today we have a CSV, it's separated with commas, and this data works really well that way. But just be aware you can have different delimiters. That's why it says delimited text and not CSV. So this interface is a little bit more complicated than the others. Up here for the file name, I'm going to click on my 3 dots like we did before to navigate to my file. And if you're not seeing the data you're looking for, there's a drop down here where you can change to all files. But text files is working well for me right now. So I'm going to pick my street tree map .csv file. I'm going to click open. So once we've selected that, there are specs here we do need to pay attention to make sure that this loads correctly. So I have my layer name. If I want to change it, I can. I think I'll leave it the way that it is. There's encoding options here. So if you have a file, especially if you work with other languages, you may have encoding that is different than UTF-8. So you can select that here. And that will take care of some of the characters that are in other encoding options. Right now we are working with a CSV, so we're going to leave that option selected, but you can do other delimiters. So if you had like tab or pipe, you can click on custom delimiters and tell it what character to be looking for instead of comma. The other thing we need to do is make sure that we tell it what geometry type we have. So in this case, we have point coordinates, so that's good. And then we want to look over here and say, okay, did it pick the right columns for my X and Y field? And it usually does a good job guessing if you have a latitude and longitude column, or if it's called lat lon or lat long, it's good at guessing that. If we had Z and M fields, we could also put those there, but we don't in this case, so we don't need to worry about that. The other thing we do need to worry about is what is the geometry type, the geometry CRS. So what is the coordinate reference system? And we won't get into projections today, but this is basically the math that goes on behind the scenes in the computer to display the coordinates properly and to know where they should be living in the world and how they line up with each other. So we just need to make sure right now that we pick the right one. And let's see, in my notes, looks like we want 4326, which mine is listed as. You can click the drop down menu and pick if you've got options there. If not, you can also click on this button that looks like a little globe wearing a conical hat because it's conical projection. And in the filter, I can just type in 4326 and it will find the EPSG code that I want. And I can pick that from the list. That's the nice thing about EPSG codes. We won't get into that today. If you're curious about projections though, Data Lab has a projections workshop that will probably run next year. So keep an eye out for that. And we'll talk all about what all EPSG codes mean and projections and all of that stuff. So again, I'm picking EPSG code 4326 or WGS 84 is the human readable name for that. Basically, this is lat long. It's unprojected. So I'm going to click OK because that's good. And then finally, in this interface, it's nice because it gives me a little preview of the table. So if I pick the wrong delimiter and all this just came out as one big mass of text, then I could go back and fix it. But this looks good. I've got columns. Looks like the data is pretty well matched in the columns itself. It's got the same kind of data. So I think we're good to go. So once all that is set, I'm going to go ahead and click add. And this file is big. It might take a little while to load. If you move the interface out of the way, you'll see it's adding points. It kind of looks like marching ants, especially because mine are brown this time. Sometimes, again, they're different colors. Yours will be probably a different color. Okay, so we've loaded all our data. So I'm going to go ahead and close my data source manager. Click close or click the X, either way. Okay, we have data. I promised you it would show up. We have some very unfortunate color choices, but our data is here in our data window. And you can see we have data now listed in our layers panel or our table of contents here on the left side. We've added data to our project. This is really exciting. You now have done GIS. Congratulations. The next thing we really need to do, though, before we do anything else, is save our file. You may notice up here at the top, there's a little asterisk next to the untitled project. That tells me it hasn't been saved. And once we give it a name, it'll have the project name. But every time there's an asterisk, it means that there's data that hasn't been saved. So save frequently. Crashes happen. Not super often with QGIS, but sometimes it does happen. So I'm going to click, you can either click the Save Project button or go to Project menu and pick Save. So I'm going to click Save there, and it's going to ask me, where do you want to put it? So I can navigate to where I'm going to put it. Again, it remembered for mine that I had already accessed my workshop data folder. So I'm just going to go into there and I'm going to give my project a name. Let's see. What did I suggest that we name this? Looks like I didn't necessarily have one. So we can call it whatever we want. So I'm just going to call it QGIS workshop. The way I actually name these oftentimes is depending on the project, I'll give it a name that I can recognize outside of the folder that it lives in, because when it shows up on the menu when I start up QGIS, sometimes if I just put like data exploration, I'm like, data exploration for which project? So sometimes I'll give them really elaborate names so that I know what they are in the menu that comes up, but name them however you like. You'll come up with your own system as you work with this. But I definitely recommend something that you'll recognize later. Okay, so we've saved. Later on, we can always come back and click the save button or go to project and then save again as we make changes. Oh, I clicked on the wrong spot. I'm just going to drag that back over. So right now I have this tool selected that looks like a little hand or a little glove. That's the pan tool. So if I click and I drag, I can just move stuff around. For those of you who are like, whoa, magic, that's what was going on there. Okay, so we're going to work with the raster data to start. What I'm going to do is come over to my layers panel and I'm going to turn off, I'm going to uncheck all of my vector data. So all I'm going to have showing right now, the only thing that's checked is the DEM data. So this is my raster data. If we zoom in really far, if I take my zoom tools here, I can zoom in. If I zoom in really super far, I'm going to draw a really small box here. You can start to see the pixels. Maybe you can see the edge of these squares. I don't know how well you can see that with the zoom share, but if you zoom in on yours, you'll be able to see itty bitty squares. So I promised you raster data was made up of a bunch of grid cells, and it is. What I'm going to do now to zoom back out is I'm going to right click on my DEM in my layers menu, and I'm going to click zoom to layers. That's going to zoom back out. Okay, so we have grid data here, and it contains elevations. What I want to do is first, we're going to style this data so that we can actually kind of see better what information is in here. If you're familiar with the peninsula of San Francisco, you know, like this is where the Bay Bridge is. There's peninsula here and peninsula up here. But if you're unfamiliar with San Francisco, this just looks a little bit wacky. It kind of looks like clouds. So we're going to fix that. What I want to do is add a tool to our screen that's called the layer styling panel. So I'm just going to go over to any of the blank space on my toolbars here. I'm going to right click and it gives me an option to see what other panels and toolbars I can load. In the panels menu, I want to add this layer styling panel. So again, I right click in any of the gray space, and then in the panels menu, select layer styling panel. There's also, you can find it in the view menu as well. You can add a panel from the panels menu and pick layer styling panel. So that's another option to find it. I think there's a third way to add it, but I don't remember, and 2 is good enough for now. Okay, so we have our layer styling panel open, and this is the tool that allows us to change the way that the data is displayed. We're not altering the data, we're just changing how it looks based on the underlying data. We'll change the colors and things like that. Because I have this activated in the layer menu, it's also here in the layer styling panel, it's selected, but if I needed to change it, I could click on that and pick the DEM. So you can see it is telling us right now we're styling it as a single band gray image. But if I click on that single band gray image, I can pick another option. And I'm going to pick single band pseudo color, which sounds a little strange, but I promise you it's the one we want. So again, I'm picking single band pseudo color, and it looks like a little rainbow box next to it. Data went away. That's all right. The first time this interface showed up and it changed a little bit and my data disappeared, I kind of freaked out. Don't worry, we will get it back. It's still there. It just doesn't know all the answers to the questions it needs to be able to style it. All right, and we are working in the Symbology tab, which is in the notes. It defaults to that, so just be aware that there's other tools down here on the side, but we want the Symbology one. Looks like a paintbrush painting a rainbow. Okay, so we've got single band pseudo color. I think I want to change my min and max settings, so I'm going to open up this part of the menu. If I click on it, it will expand and contract. What I want to do is I want it to be set to min max for the whole raster. Instead of estimate for the accuracy, I want actual. It warns you that it's slower, but we have a really small raster. If you had a really big raster, you would want it to do the estimate option, but because we have a small raster, I actually want to look at all the values so we don't miss any. Otherwise, it's going to take like a 10% sample and it will miss some of the highs and lows. And that will matter with a small raster in the way that we work with it. You can play with it and see what the difference is. It may not make a huge difference, but for smaller rasters, I will have it use all of the cells for the accuracy. For the interpolation option, this changes the way that it's going to bin the data. I think I want it to be discrete. So I'm just looking over at my notes and making sure I'm in the right spot. Yeah, so I want to change this interpolation option to discrete. So what that's going to do is instead of making a color ramp that's stretched across all the colors, it's going to make discrete categories. You can think like a histogram. So it's going to bin the data and make certain categories. Let's see. For the color ramp, this is where we're going to actually start to see the data. If I click on the little drop down menu, it gives us color ramp options. What I want to do is tell it I want to create a new color ramp. And this is going to give me access to some of the pre-made color ramps that I can pick off of a bigger list. So I picked create new color ramp, and instead I could make a gradient myself, and I have done that. They're tedious to do, but you can do that, especially if you need specific colors. But what I want to do is pick from the catalog, specifically the CPT-city catalog, and you'll see it's going to open up a new list of options for us. So again, I picked the catalog CPT-city, and I'm going to click OK. And this is going to open up a bunch of pre-made. Oh, it picked one. That's definitely not what we want. We will fix that. The one that I want is down on the side. I want to pick topography from the list of, these are kind of like collections of options. And then in the topography collection, I want to pick CDA. And the reason I want this one is because it has blue on the low end. Because we're in a coastal area, I want my zero values, basically my ocean, I want to make it blue because my brain will understand that better. And then I have a range of other values that are similar to topography, like low-lying areas will be green, higher levels will be brown, up to white for, snow-capped mountains, which is less likely to happen in San Francisco, but our brains will still understand this, this color palette really nicely for elevation. But feel free to play around with the other options. There are a lot of pre-made options, and there's also, you can make, your own and go wild and pick things that you want to do. Okay, so I'm going to pick OK because I picked CDA and that's the one I want right now. And we haven't finished doing the selections on this, so it's still a little bit crazy. It's a nice yellow color though, but it's really not helpful for displaying my data the way I want it. So we're going to keep going. Okay, then let's see, label precision. We don't need to worry about that. For the mode here, I want let's see, I think we want, what does it say? Okay, for mode, I want equal interval. I was looking in the wrong spot in the materials. So I want to pick equal interval. And then for my number of classes, I want 10 classes. So I'm just going to click the up button here until it says 10. So I've got 10 classes, and you can see like we're already starting to see the land a little bit better, but the classification isn't quite what it needs to be to make sense. So we've got our color ramp set. We kind of have a flavor that this is a pretty good choice of colors for topography purposes, but these breaks just don't make sense to me for how I understand the data, because I think of the blue class in my mind is kind of like water. So I want my break to happen at 0, because that's 0 elevation is where the water is, because we think of elevation as like units above sea level. So for my value here, what I can do is just double click on the value and it will allow me to edit it. And so then I can just type in 0 and you'll see what happens immediately. Now my break is from less than 0 to 0. And now I can see my shoreline really well. You can kind of see some of like the docks and low-lying areas a little bit better. And you can play with this. Maybe 0 isn't what you want. Maybe you want to set it to like 1 or 5 to adjust for, you know, some error in the data set. But for now, this looks good. You know, we can play with this more. If this was for research or display purposes, we would spend a lot more time on it. And you can see in the workshop materials, I've suggested some breaks that I think work well with this data. And obviously you can play with them. You can change them how you want. But for my second break, I had 50, and you'll notice how the colors change as we go. So we're not changing the underlying data. We're just changing how they're displayed. So any pixel that's less than 0 to 0 is getting colored this bluish color. Anything from 0 to 50 is that lighter green color. Up to 75 is now this yellowy green color. So it's not changing the data, it just changed how we colored it so that we can see it better and we can understand the relationships better. So I'm just going to put in my little breaks here that I've chosen. So 0, 50, 75, 125, and you can see all of the breaks in the workshop materials if you want to follow along. And honestly, I would say after you add like 3 of them, you probably get the picture. You don't have to go through every single one if you don't want. But I'll just go ahead and do this really quick so we can see what kind of difference it makes. So the way that I actually chose these, because I was working, you know, for visual purposes, I actually played with them for a while and then decided like, okay, this looks pretty good, and then set them to even an even set of breaks just to make it easier for the workshop. And you kind of have to think about your audience and your purpose for how you're setting these. And then my last one is infinity. So it's everything beyond that. 350 and up will be one color. So you can see how our color ramp that's shown here, how it's getting applied to the different elevations. We have everything super low level looks like water in our color scheme. And then everything else has kind of land type colors, terrestrial colors up now to, you know, white mountain peaks. Sometimes these mountains get snow, but not very often. But in terms of our visual understanding of this data set, now I think it's a lot more clear what's going on and that this is actually elevation and where the actual shoreline is. So now we've styled some raster data, and hopefully you've gotten a little bit better idea of how raster data works and how we can display it. There is a lot more you can do with raster data, and you can spend a lifetime learning just how to work with raster data. And I've got a link to more training material in the workshop material. But the point of today is just to give you the flavor of it and get you some experience working with the data type so that you can now go forth and learn more about this one. All right, so what I want to do is click save now. I'm going to click on my save button. So just in case it crashes, we can come back. Hopefully it won't crash. QGIS is pretty stable. And I want to pause here and see if there are any questions that you guys have about the raster data. Remember that our helpers can help you if something's going wrong. If you're trying to follow along and you have questions, you can ask there and they'll help as we go. But if you have any concept questions, we can address that now, or we can address it later. There'll be hopefully time at the end for more questions. So I think what we'll do, I'm not seeing any questions, but keep typing if you're typing and I'll get there. The next thing we're going to do is we're going to work with some of our vector data. So we just did raster, just scratch the surface of raster data. You can imagine there's a lot more you can do with raster data with things like satellite data and drone imagery and things like that. But again, that's a whole nother workshop. Actually, I imagine probably with the Earth Engine workshop, we'll be dealing with more raster data, but yeah, so keep coming to map times if you want to learn more stuff. So, all right, I've paused long enough. I think if anyone had a question, we'd probably see it. So I think we'll motor on and jump into working with vector data. So let's go ahead and we're going to go back to our QGIS, shift our focus over here. Let's see. I am looking at the materials, just making sure that I'm not missing anything. Okay, so what I want to do is I'm going to turn off my DEM. It's a pretty DEM, but we want to work on other things. So I think we want to start working with our street. So I'm going to go ahead and check the check box next to our street center lines. And so you can see, maybe you can't see because mine's really small. I'm going to right click on it. I'm going to click zoom to layer just so that it kind of fills up the space. It just zooms to the extent of my layer that way. So you can kind of see now maybe a little bit better. We have a bunch of lines here and these lines represent the streets in San Francisco. They are all styled the same and it picks a random color. So yours will not necessarily be this lovely shade of taupe that mine is. You'll probably have some other color. And like I said, when I've taught this workshop before, it was picking all hot pinks for everything. I don't know how it decides the color, but this is what we got. So we don't have to keep it though. We can change it to something else. So you may have noticed as if we click on different things in the layer list, our layer styling panel changes to whatever we've selected. But if you want to make sure, you can always click and choose what object you're working on with the drop-down menu here at the top. So right now, it is set to a single symbol, which I think is fine for what we want to do next. Let's see. One of the interesting things about this is you can kind of build up your symbology in layers. So that's why you'll see you have, it says that it's a line here, but then we also have this simple line. If you click on simple line, it gives you more options for picking of different parameters like color and the size of things and the type of, is the solid line, is the dash line. So what I want to do is, I don't like this taupe color. I think we can do better for roads in terms of communicating. So I'm going to click on my color here and it's going to give me an interface where I can pick colors. There are a bunch of tabs here at the top. There's 4 of them. And if I click on different ones, you'll see you have different color interfaces for different color choice tools. Each of them has its own kind of flavor of how it works and is useful for different things. You should play with it and see which one you like better. I'll switch back and forth between them depending on what I'm doing. But with each of them, you can pick the color off of the color choosing thing. And then you can also adjust things with the hue, saturation value, and the RGB values here. The other option is, honestly, I use this a lot too. There's HTML notation down here. So if you have a color you really like that the HTML notation for, or you can go online and Google different colors and play with different color tools, you can also pick your colors that way. So you have a lot of options for getting the precise color you want. So if I wanted a gray, I could kind of click here and say, okay, this is a nice gray color. Maybe I want a little darker. I can play with the value here and make it darker. And I honestly can spend a lot of time even picking grays because that's how my brain works. But another option is in the workshop materials. I told you that I changed the opacity. I want it fully opaque. Be aware of that. You can make colors that are see-through, which can be useful, but a lot of times we don't want that in maps. If I want to change my HTML notation to be a precise color, in the workshop materials, they suggested that if you enter all 6s, okay, so I have 6 6s in there, that will be, and I have to hit enter, that will change it to a dark gray. And so you can have the exact color that I have if you want. to do this. Okay, I'm seeing a question that somebody lost their layer styling panel. Good question. So again, how we find that is the easiest way probably for me to get you there is to click on the view menu. And then once you open the view menu, you're going to slide down to, I think we want panels. Yeah. So for view menu, then the panels menu, and then pick layer styling panel. So that should get your layer styling panel back if you closed it or you moved it somewhere. Also note, you can undock these things. So you may have it floating off in a different place on your screens as well. It's very customizable, but that is not helpful for teaching workshops when everyone can have it in a different spot. So hopefully you can find that. Okay, good. Doug says he found it. Good. Okay, so again, you can have the same color I have, or you can pick a different one. It's totally up to you. You can play with these different options and choose colors that you like. All right, so gray roads make sense. I tend to go very simplistic when I'm making maps. I want to communicate things well. And if I made all of these things blue, you might be wondering why there was suddenly canals in San Francisco running through the city. So gray communicates that this is a road, very simply. Okay, so that was easy, right? We styled it all one way. And we think that, at least I think this communicates better. So that's good. And if this is how I wanted to leave it, we could. And we will for now, because I want to tell you a little bit about attributes. Because later on, we're going to style things by attributes, and you'll see we can get a lot more complex with our styling. So for my street center lines, what we want to do is we can look at the attribute table, and vector data is kind of composed of two different parts. There's the geometry, so the things that make the shapes, like the lines or the points or the polygons. And then we can have an entire attribute table. You can think of it like a spreadsheet attached to each of those lines. So right now I can see the geometry, but if I want to see the attributes, I can right click on my street center lines and pick open attribute table. So it's kind of right there in the middle. So again, I right clicked on my street center lines and I'm choosing the open attribute table option. All right, mine this time popped up in the middle of the screen I'm working on, which is nice. So you can see there's a lot of information in this table. Each of the line segments here in my map corresponds to a row in my data table. And so we can have information about each of these line segments of, things you might want to know about a road. Is it a private road? Is it a public road? Is it, what's the name of the road? What neighborhood is it in? Various pieces of information that the city of San Francisco wants to keep about each of its roads. And that's pretty handy when you're working with road data. Let's see. What I can do also is, I'm making this a little bit smaller. If you hover over the edge of your attribute table and you click, it'll let you make it different sizes. What I can do is each of these, like I mentioned, each row is associated with some line segment on my my map here. So if I click on one, I'm guessing the one I picked is really small. So I've highlighted it somewhere, but I can't see it. So if I want to, I can zoom to my layer with this. I know this menu is really, or this button is really small on the zoom share, but it's kind of towards the end. And if you hover over it, it should do a little tooltip pop up that says zoom map to the selected rows. So if on your computer, you may be able to see it better. It looks like a magnifying glass over a yellow box. So I'm going to click on that. And what it'll do is it'll zoom to this line segment. If I zoom out, my line segment is here. So it's picked a very small road for this. You can kind of see in the larger context, the road segment is there. And so it highlighted it because each of those attributes, each of those rows in my table is linked to some line on my map. And now if I want to unselect it, I can just select deselect features. So you can see how they're connected. I've got my shape connected to my data, which is awesome. Let's see. And then we can, as I showed you, we've got zoom tools up here. The plus and the minus with a magnifying glass lets you zoom in and out. So if I want to zoom in, I can use plus. Minus zooms out. I can also use my scroll wheel. So if you scroll in and out, if you have like an actual mouse versus a touchpad, it'll be easier. And then I have the pan tool. Again, this little looks like a little white glove. If I click and drag, I can move things around. But also, again, you can right click on your menu item and click zoom to layer, and it'll zoom to the extent of everything so we can see the whole thing again. All right, so there's that. Let's see, so that's pretty much the standard things you need to know about attribute tables and how to work with that. Now that you've seen the data that's in our table, we're gonna start to work with some of that and make some selections. So I'm gonna start moving a little bit more quickly just because I wanna get through a couple more things before we have to end. So now's a good time if you're a little stressed out following along, just sit back and watch, and it'll be okay. You can always go back to the materials and try it on your own later. Okay, so what I want to do is I want to select things based on their attribute. I could select things, holding down control and picking all of the streets on my list, but there's a heck of a lot of streets here. Like, what do we've got? Like 16,000 features, it says. That's too many to work with by hand. So I want to do this programmatically. I want the computer to do it for me. So I'm going to use the select features using an expression button. And in the workshop materials, I have screen captures of the buttons so you can see them a little bit better. Looks like a little E next to a yellow box. You notice all the selection things have yellow because that's the standard selection color. Okay, so I want to select things by class code. Because class code tells me what kind of road it is. Is it a highway? Is it a residential street? That kind of thing. And what I can do is if I want to see all of my fields from my attribute table, so all my column names, I can expand this fields and values option in this sort of middle column. And I want to look for F code. Oh, sorry, not F code. I want class code. Thinking of another workshop. You'll get F code if you come to the SQL workshop. That's what's in my brain. Okay, so class code is the name of the column in this particular data set. And then if I want to find out what values it has, I can come over here and click all unique values. Don't click all unique values if you have a continuous field because it will not ever finish. But I know this is categorical data. And let's see, I want to look at the class code that equals 1. There's some notes in the workshop material about using like, which also will work. It depends on the way that the data is loaded, but I believe that this will work. It seems to work both ways in the newer version of QGIS, whether you use equals or if you use capital like. And you can see down here, the preview on my window says 0. That doesn't mean nothing was selected. It means that there's no errors. So I'm going to go ahead and tell it to select features. And you'll see that I can close this now. It tells me it selected 108. And if I move the attribute table out of the way, you can see class code 1 looks like highways. So if I didn't know what class code 1 meant, I could make a guess based on what it shows up as when I select it. So you can kind of see these yellow lines are the highways that run through San Francisco. So we could keep going. We could play with this and we could look at 2 and 3 and whatever. But just to cheat, I have your answer in the workshop materials. So from the metadata that comes with this data when I downloaded it, 1 is in fact freeways, 2 is highways. So those would look really similar. 3 is major streets, for example, and there's local streets and freeway on-ramps and things like that, which we'll look a little bit more closely at later. But that's how you can work with attribute data to kind of understand it a little better just through selection. And a lot of times data isn't well documented, so you do have to go through this process of kind of making guesses. But right now I'm going to unselect everything. So this little looks like a no smoking sign next to a yellow box. It doesn't delete data, it just unselects things. So I'm going to go ahead and click that. Sometimes I've had folks say, oh no, but it looks like it deletes it because it has red. In this case, it doesn't, it just unselects it. You're not deleting anything. Avoid things that look like trash cans if you're deleting things. Okay, so that's how we can do select by attribute. So we can explore our data that way. But that doesn't really, it's not permanent. Like if I wanted to make a map like that, it wouldn't work well because I can only select like one thing at a time and it's not going to necessarily show up in my map when I try to put it in the map composer. So we can do something similar by classifying attributes. So I'm going to go ahead and close my attribute table here, and now we can work with our layer styling and get a little bit more sophisticated now that we know what is in our data set. Okay, so in my layer styling panel, again, I'm making sure I've got my street center line selected. Instead of single symbol, I'm going to pick categorized because I want to categorize my data. I know I have categorical street types, and so that will work well. Again, the data does disappear just because it doesn't know how it's displaying it yet. For my value, I'm going to pick class codes so that I can classify based on what kind of street it is. We just learned how that works. The symbol and the color ramp are all fine. You can choose a color ramp, but we're going to fix it in a bit. So I'm going to go ahead and tell it to classify, and it's going to pick random colors. It looks kind of like a leprechaun party because it is green. It doesn't always do this, but it's pretty festive. We're not going to leave it this way. So you can pick colors if you wanted to. But because these are all streets, I kind of want to make this different line weights. Like I like the idea that the streets were gray before, but I kind of want to make the big important streets wider so that they have more weight and they take up more space visually. We can do that. So what I want to do is I'm going to click on my first symbol. I'm going to click on my last symbol down here, number 6. We can uncheck this guy at the bottom because everything's classified. So I've highlighted, clicked at the top, held down shift, clicked on the bottom. So I've got them all selected. I can right click and I can say, let's change the color of everybody together. And so it opens up my color picking interface. This looks familiar. We've seen this before. And then looks like I picked a slightly different gray color for this section. You could go back to the all 6s, but this is alternating A's and zeros. So A0 3 different times. I'm going to click OK. And now I just change everything to the same gray. Like, what are we doing? What I want to do is I'm going to, now that I've picked the color I want, I'm going to go back. I can just click anywhere to unselect stuff. And now I'm going to change the line width. So what I want to do is in the legend, if I click on legend here, I can change the label. So, and this will actually change it in the attribute table too. So 0 is private streets. I'm going to double click on 1, and that's freeways. 2 is highways, which are pretty much similar. 3 is major streets. Type that in. And so all of this information is in the workshop materials. I don't have this memorized. So 4 is secondary streets. So you can kind of get an idea of the hierarchy that's going on here. 5 is local streets. So you think of those as kind of like neighborhood level streets. And then 6 is freeway on-ramps. Freeway ramps, that's what they're called. Okay, so now I've labeled them. And if we actually expand over here in our layers panel, you see that the labels are actually showing up as we put them, which is nice. And now I'm going to change the line width for each of these. So if I double click on the symbol next to the 0, it will let me change the line width. And I have a table of weights that I want. So in this case, for private streets, I'm going to leave it as 0.26 millimeters, so I can go back. For freeways, for number 1, I'm going to change my line width to something pretty fat. So it's going to be 2.0. And this is a little heavy, but it illustrates the point. Same thing with highways. I want those to be similar because I feel like highways and freeways are pretty much the same thing functionally. So that can also be a nice fat line. Let's see, major streets can be 1. Oh, not 10, 1. That's better. So you can see they're slightly less thick. So we've kind of got a medium weight line for the major streets. They're major, but they're not freeways. So they're kind of in between. So it looks like secondary and local streets, I'm going to leave with the default 0.26, and then I can change the freeway on-ramps to, looks like I chose 0.5. Okay, so now we can kind of get an idea of sort of what the different streets are in the city. And based on how this is looking, I would probably adjust some of these weights a little bit to make them more to my personal map style, but we won't take time to play with that and make it perfect right now, because I think you get the idea that I can categorize my data and use color, but I can also use line weight to differentiate my data types. And I think this communicates the streets rather well for the different types of streets. Like, you wouldn't need to know necessarily that what the names are, you would probably, if you saw this, be like, oh, okay, the fat lines are probably the freeways or the major streets that I need to be aware of. And then the smaller streets are things like neighborhoods or like, for getting to a specific business or something like that. I wouldn't necessarily travel on those. I probably want to stick to the bigger ones to get all the way across the city. Okay, so we have now, I'm going to click save as I transition, save your work. So now we've had a chance to see how we can work with our attribute data. Remember, all of this information is being pulled directly from our attribute table about the different categories of lines. So that's pretty cool. Now you really have done GIS because you've worked with your underlying data to symbolize both raster and vector data. So if you thought GIS was hard, maybe it doesn't seem so hard yet, which is good. Do we have any questions about this that I can answer? What I'd like to do is push on and finish up the rule-based symbology section of the workshop, and then I think that's probably what we'll have time for. And if we go quickly, we might actually get to the map, but the materials will always be online. You can finish up those last little bits on your own. Okay, so I have a question. Can you remind us which data set layers are vector and which are raster? Great question. So in the data that we've loaded, everything is raster except for your DEM. Your DEM is your raster data. The other ones are vector data. Sorry, I think I bungled that up a bit. So the only raster data set is your DEM. And if we click on that to show that, remember, if you zoom in, you'll actually see pixels. It's continuous. It covers the entire area. So that's a DEM, it's raster data, and then your vector data are things like your trees, your center lines for your roads, the shoreline, and the seismic hazard zones. Yeah, Alex points out that the layer panel actually shows you because the points has a point symbol, the lines have a line symbol. The polygons are a little square, so a polygon, and then the DEM has this checkerboard because it's grid data, so they're reminding you that it's grid cells. That's a good question. Oh, we've got a big question. Okay, so Alyssa, remind me at the end if it's a question for the end, because it looks like a big one, and I will definitely answer it, but if it's for later, then just remind me and we'll get there. Okay, cool. So I think what we'll do is let's jump into some rule-based symbology, because this is really powerful and it's helpful when you've got a big data set and you don't want to look at everything. So what we're going to do is we are going to look at our tree data now. And I'm going to load this. Be patient with the tree data set. It's really a big data set and it takes a while to load. And you can see it's way more data than we want to make a map with. There are a lot of trees in the city of San Francisco. So these are all the trees that the city manages. There are more trees than this in the city. It's kind of nice though, right? Like lots of trees is good. So these are points. Each individual point is an individual tree. We can look at the attribute table for this to get an idea of what is in here. It's probably going to take a second to load just because it's a really big data set. I'll probably only open this once to show you because it is so slow, especially Zoom. For those of you trying to work with QGIS while you're obviously listening to the Zoom session live, it's going to be even slower because of the way your computer works. They're trying to compete for the same resources. So if it's slow, that's why. If it's extra slow, that's why. It will speed up when we're done with Zoom. So you can see in this data set, we have a lot of information about all these trees. We have some information about the legal status. We have the species name. I can expand this if I want to see the whole species name. Notice they actually have two pieces of information in the species column, which if you're doing a database, I don't necessarily recommend because you'll see it's going to make things a little challenging to select later. But it's good that we know that it has the Latin name and then 2 colons and then the common name for the tree. So that's good to know. We have an address, so we know where the tree is located. If we needed to go, say, we're on the tree crew and we need to go fix a tree that maybe a branch broke or something like that, or a tree needs maintenance, we'll know how to find it, not just with a GIS point, but actual something we can put into our turn-by-turn directions. So we have some information about the site, like, is it in a sidewalk? Is it not? Anyway, tons of information about these trees, including latitude and longitude, and also the DBH measurement for non-plant people. DBH stands for diameter at breast height, and gives you an idea of like what the circumference of the tree is. How big around is this tree? About 3.5, 4 feet off the ground. So that gives you an idea of how big the tree is, and that correlates with height for different species. So they have an idea of what size this tree is at the moment this data was taken. So a lot of information and a lot of trees. I'm going to go ahead and close my attribute table now that we've looked at that. And you can imagine there's a lot of reasons why you'd want to subset this data. And in the workshop material, I have this fictitious problem to solve where you're interested in finding where the canary pines are because of invasive pine beetles. This is a legitimate thing. Like, there are actual invasive beetles that attack canary pines. So you might want to know where they are so you can check them to make sure that they don't have this parasite. So what we can do is, if we just want to see where the canary pines are and we don't want to subset our data, we just need to make a map, and we don't need to separate all this out. We can decide, instead of doing single symbol like we've got, so we've got street trees selected at the top, instead of single symbol, I can pick rule-based. And I wouldn't want to do categorized here because there's a lot of different kinds of trees. So I just want to separate out and only show the canary pine. So it's made a rule, which is show everything. And if I double click on my rule with no filter, I can add a filter, and we're going to add things to this and tell it, don't show all the trees, only show the canary pines. So for the label, I'm going to put in canary pine, so that I can remember what this filter was later and don't have to read the filter. And then I'm going to pick this little Sigma button here next to the filter, because I'm going to use the interface to make my filter. And this is going to look really similar to what we did earlier when we were looking at the streets and seeing which class code we wanted to use. So I'm going to, again, go over to my middle panel and open up fields and values, because that will give me my whole list of column names. I'm going to pick Q species because that tells me the species name. And now we're working with text. So instead of using equals sign, I'm going to use like. Like's a comparison operator for text. And we saw in the attribute table that the species name is pretty long. And if I'm going to add 10 samples here so we can kind of get a preview of what that looked like. We may not get canary pine, but we can see we're going to have to either find canary pine on the list, or we're going to have to guess. And I don't like that. So what I want to do is use a wildcard instead, because I know that the name has canary pine in it, but I don't want to have to go look up, what the oh, sorry, I was going to say I don't want to have to look up the Latin, but I do have the Latin in the workshop materials, so we'll go with that. But we can make this easy and just do a wildcard search. So what if I just search for the Latin name? So if I just put in Pinus canariensis, I have to spell it right there, though. Okay. It's not going to find anything because it's not going to match precisely, because I'm not using this whole string exactly right. But I don't want to have to really guess. So what I can do is use wildcards. I put a % at the beginning and a % at the end. What that's going to do is say, QGIS, please go look through my list of species. And if the species contains this set of text anywhere in the string, go ahead and consider that a match. And so it likes that, it will work. And if I click OK, hopefully this will work. We will see if I got this right. If not, we will make adjustments. It might take it a second. I bet I misspelled the species name. So what I'm going to do is I'm going to copy out of the workshop materials just so we can see how this works. I'm going to erase that and paste in the right one and tell it OK. Apply. Go back. Huh. Maybe it's just slow. I think Naomi told me earlier when she was trying this that this one took a while to load. So maybe we'll just give it a second. Otherwise, if it doesn't load, so what I'm oh, here it goes. Yay. What I was expecting it to do is what now it's showing on the screen. And yours may be a little slow as well. So now we've whittled down that huge pile of trees into a few points on the map. And all of these are canary pines. If we want to check, we can use the identify tool up at the top, this little blue circle with an eye in it. And if I click on one of these, it'll open up oh, this might be slow. There we go. It'll show me what the attributes are for it. So we can see that it is in fact canary pine, and we could check on some other ones, but I'm not going to tempt fate now with a big data set. So we'll use back to the little pan tool. So all of these are canary pines, and now we could actually make a map with this. And you can see that like you could actually make other rules. Like maybe if I wanted to make a map with canary pines and maybe another species, like I know there's carob, for example, in this data set, I could make a map of canary pine trees and carob trees. I don't know why I would do that, but I could. So you can add more filters, and then you would have more points on the list that you could symbolize differently. And again, if I wanted to change the color, like brown trees is kind of sad, so I can click on that point and I can pick a green instead. I think I have one on my list. So this is the list of previously used colors. It doesn't have one, so I'll just pick a green. That's probably a fine green for this. Certainly better than brown. So we'll click apply, click back, and now once it reloads, it'll eventually have green points once it figures out which ones it wants to display, and it'll just take it a second. So now we have a map of canary pines, or at least we have data separated by canary. We've pulled out our canary pine data that we can visualize. So if I was sending a crew out to check the canary pines in the city, I actually would probably send them to the street, for example, because there's a lot of trees here. So I would assume if we're gonna, end up with any kind of problem with canary pines and the bark beetles, this would probably be a good place to look, or this kind of grouping over here too. There's a lot of them. So it'd be a good place to get a bunch of trees to check all at once. So you can see how this can be applied to real world problems. Like maybe you're not interested in street trees and, bugs and things like that, but you can apply this to your field. Alex, do you have your hand up for purpose?
There was a question in the chat.
Okay.
About overlaying temperature data, which I think you could demonstrate with overlaying the DM data.
DM, yeah, good question. So temperature data would look really potentially similar to the DEM because elevation and temperature tends to be related. But yeah, you could have temperature data. Oftentimes that comes in raster format because it's continuous data. So it makes sense for it to be a raster, although you could have vector data. But so you could have a similar situation here. It'll help if I turn off the streets. Let's say I was interested in finding out the temperature, or in this case, the elevation for each of my trees. I can actually extract the elevation for each of the trees for the points at where they coincide with the raster data. So yeah, you can work with temperature data. You can work with elevation, all of that together.
Would you be able to do, oh yeah, rainfall as well? Yeah. Would you be able to overlay like several raster data layers?
Yeah, the trick with raster data is, yes, you can work with it all together, but the tricky thing about raster data is it's continuous, right? It covers everything. So if I'm trying to make a map with two rasters, I have to figure out how to display them together. And often the answer, if I'm trying to do that visually, like say I'm making a figure for a journal article, is to put them right next to each other, two panels, like here's elevation, here's temperature. And if you style them carefully, people will be able to reference between them. But because they're rasters, they block each other out. They're like, you can think of them as sheets of paper versus like vector data is kind of like cutouts. So hopefully that analogy is helpful. So you can work with them together. You can put them in the same GIS. You can query both data sets. But the only tricky part is when I try to go to make the map itself to display and put information in a static form in like a journal article or a presentation. Raster data blocks each other out. So they kind of compete and they're a little bit trickier to work together. So hopefully that helps. I'm happy to answer questions like specifically about your research in office hours. So feel free to come by. We have them Wednesday afternoons. You can go to the Data Lab website and find out specifics about that, but I'm happy to talk specifics about how to work with your particular situation. Then it's hard to answer like general in workshops, but I can definitely talk specifics with you later. All right, so we've got a couple minutes. Are we feeling good? Can we blast through how to make a map? Thumbs up if you ready to go, or check mark. I see one person's good. All right, yes, good. All right, let's do it. Okay, so we've seen now how to style our data. We've gotten our information to look a little bit better and to communicate more precisely what the data contains. And you can play with all of these things a little bit more and get them, more to your liking. But the important thing to know is before we start our map composer, I kind of want to have everything about the way I want it to look before I dive into like putting it actually in a map. And I'm just noticing I have my little asterisk here, so I'm going to click save before I open the print composer. So to open the print composer, I'm going to click on project, and then I'm going to click on new print layout. This is because we don't have one started yet. If I had one, I could click on layouts and it would have the ones I've already made. But so I'm going to click new print layout, and it wants to know what I want to call it. So I'm just going to call it trees. You can call it whatever you want. I often guess wrong, and later my map names are a little bit nonsensical, but it's fine. As long as you know what they are, it doesn't matter. Okay, I have a map. It's blank. What I want to do is I'm going to right click and click on page properties and tell it what paper size I want. I will tell you, if you're making journal article maps, and we actually have a workshop on how to specifically work with journal figures, it's going to be a really small size, but we don't have to deal with that right now. So I'm going to pick letter and be very extravagant and take up a lot of room. 8.5 by 11 inches in my world as a cartographer who makes a lot of journal figures. This is huge, and I have so much real estate. It's blank. I need to actually add every item I want on the map. It's not going to make any assumptions. What I want to do is I want to add a map, and I honestly forget what all of the buttons do. So I just hover over them until it gives me the little tooltip. So I find the one that says add map. I'm going to click on that. And what I want to do is I'm going to click where I want the map to start. I'm going to drag across to where I want it to end. And I'm just letting it snap to the corners. And then when I release, it's going to make the map. If you make it the wrong size, don't worry, we can resize it. There's the little handles here that'll let us make it a different size. And there's options also. You can type in the precise size you want. Now it's taking a minute to render, and that's fine. Okay, look, our map. Yay, that's very exciting. What I want to do is make sure I'm using my pointer tool over here. The other tools sometimes will operate different things on your map. Like if I want to recenter it, there's a recentering, like move item content, but I want to use the pointer right now. So I've got my map selected, and over here I have the scale option. So as I change these numbers, it's going to zoom in and out. So I'm going to try for 4,000 and see how that goes. And this will take a little bit to render. Oh, I wanted one more zero. And change my scale by an order of magnitude. So I can zoom in a lot, but I want it zoomed out kind of more to the city level. The other thing to note is you can use the scroll bars now, or the scroll wheel. If you have the move item content selected, I can zoom in and out with the scroll wheel. But I'm just going to drag it right now. I kind of want to line it up on the bottom so that you don't notice that I don't have street data for the rest of the peninsula. And it's going to recenter that. Okay, so I've got my map in there. These layers are good to show what I've been working on today. Certainly if I was working on this for like research purposes, I'd probably make some different choices, especially a lot of journals won't take color. So I'll have to find a way to style that in grayscale, but we're not worried about that right now. What I can do is if I want to add a title to my map, I can add, there is a text option. Maybe that is the one I want, add label. So I'm just going to click, and it's going to ask me what size and width. I don't worry about this. I just click OK. It makes a giant text box, and I just fix it later. So I'm going to call it Canary Pines in San Francisco. So there's my title. I'm going to scroll down a bit. Okay, there's no OK option. It's already there. It's just really small. So I can play with the font here. If I scroll down, I can click on the font. I can pick a font off the list, like maybe Calibri is good. 10-point font is way too small. Let's try 20. Maybe we want to make it even bigger because I want it to really stand out. Let's try 40-point. So this is kind of the process I go through when I'm making the maps. I'm always just kind of playing with it and seeing what I like. This text box is way too big, so I'm going to use the handle here. I'm going to drag it, make it smaller, and I can reposition it to the top. In fact, maybe I'm going to click on my map. I'm going to actually make the map a little smaller so I can put the title at the top. But you get the idea. There's a lot of options that you have to play with and kind of adjust things. Maybe also, now I want to recenter this a little, move that up. I can add a legend if I want. I wouldn't honestly put one on this map because I could use the figure text to say what it is and people would know maybe. But you can add a legend with the add legend button. You can add a north arrow. There are some, I put a north arrow, again, I just tell it okay and I mess with it later. Wow, that made a large one. We can make that smaller with the handles. You have north arrow options that are loaded and you can make your own if you really want. So I can click on arrows and see what my arrow options are. I tend to favor smaller north arrows unless I made north not up, just because it's not about the north arrow, it's about the data. So I'll make that pretty small and stick it in the corner. Some of these north arrows have parameters that you can set, like maybe I want, instead of having it white in the center, I want to make it gray to match my roads. So I can, some of these have parameters that I can change and fill in different colors and things like that. I can add a scale bar. And I can, again, change the parameters on the scale bar. It made a really big box that I don't need. So I'm just making the box smaller because there's really nothing in it. I can change things about the scale bar, like how many segments it has. I can change the units. I can change the height and things like that. And you can actually change the fill too. Like I often will change these to gray so they don't stand out as much because again, it's not about the scale bar, it's about the map. So the scale bar is just for reference. So I tend to make my extra things they call decorations. I make them small and inconspicuous. People will find them. But this is how you make a map in QGIS. Every item that you want to add needs to be added. It will not assume you want anything in particular. It will make you add it, which is a good thing to know as you're starting out making maps, that you've got to add everything. Sometimes that blank map to start is pretty daunting and you're like, how do I get the map on there? You have to add it. So that's the basics of making a map. If I want to export this now, I can save it as, it's not doing my tooltips. This button here makes, there we go, export as image. That's what I would recommend. It'll let you choose pretty much any image format like JPEG, PNG, that kind of thing. And then it'll ask you about the resolution. You can also export a PDF as well. A note about exporting SVGs. This is a really good option if you're going to bring it into, if you want to bring in your map as it is into Illustrator or Inkscape or another vector illustrator tool. But there will be some challenges with clipping. It doesn't clip precisely to the bounding box. You get a lot of overhang, so you have to do your clipping again in your art software. Which I kind of like it that it doesn't clip very closely, because then if I need to make some minor adjustments, I can do that in the art program. But that itself is a whole nother workshop for how to work with the art programs after you get to this stage, which I can do if people are interested. We can do that next school year. So yeah, this is, I hope you've gotten a good introduction, and I'm going to click save. Sorry. Hopefully you've gotten a good introduction into QGIS today. I want to leave a couple minutes for questions. There is in the workshop materials, we didn't get to the select by location stuff, but you can run through that on your own now that you've got the skills and the understanding of how to work with QGIS. That should be pretty easy to do following the steps as they're written out. So thank you all for coming. I will hang out for a little bit and answer questions, but I'm going to stop the recording so that people can ask whatever they want to ask and not be recorded. So just give me a second on that. But again, thank you all for coming. I'm really glad that you were here and hope you learned something.